Hey, so before I move on to the next section, I wanted to briefly mention that you can do something like this too. So you can do if hit dot b blocking hit is not equal to 0 or is equal to true, then you can go and declare this vector called impact, and then you can get the location from that hit that we declared up here. That again we use in this add active world offset, and then I go and do the log. So this is useful if you want to avoid all of those zeros that I mentioned previously that we saw. So if you don't have any collision or an impact, in other words, then it will just print a bunch of zeros, which is not that useful. We only want the information where it actually does have an impact. And also in this way, you don't have to go and declare and initialize this vector and print it out unnecessarily with each tick. So just do this single check, and if it's false, you just skip it. So it's kind of more efficient this way. Alright, so how did I get this here, this B blocking hit? Well, I actually showed you previously this F hit result. Right click on that, and I'll just pick the definition. And right at the top here, you have this. So I mentioned that this is similar to a Boolean, and this indicates if the hit was a result of blocking collision. Otherwise, it was an overlap or a touch instead. So I showed you this previously, and I just wanted to kind of highlight how you can use those members to, again, maybe have a more efficient tick function and to also do a check, because again, it's kind of silly to print out all of those zeros. Right, so I've already built this, and if I click play now, my output log, you won't see anything. But as soon as we have a hit, you'll see that it will start printing out that impact location. So just a quick bonus here that I wanted to highlight to you. And what I'm going to do now is I'm actually going to go and delete all of this stuff. You can comment it out if you want, but I'm not going to use it anymore for right now. I'll uncomment the line here where we add the impulse to that chair component. So let's look at how we can destroy our actors. Okay, there's a simple function here called destroy, and that will destroy the actor. Now for this example, this will not be very useful. In some cases it is useful to use this particular function. So let's say you are building a game where you are catching balls or something like that in a bucket, and as soon as you catch the ball, you want to add to your score, okay, of your game, and then maybe you want to destroy that actor as well. Instead of having it fill up the bucket, it might be more efficient to destroy things in some instances, or if it goes off of the screen, so outside the play area, then you want to make a check for that and destroy it in that case. So let's just see what happens. I'll Control B to build that, go back into the editor here, and I'll actually just click play, and as soon as I click play, that actor will actually get destroyed. I'll just stop here, and we'll get errors because what we have to do is we have to enable simulate physics. So go and make sure that it's set to movable and enable simulate physics, and that is for that add impulse function. Otherwise, again, you'll get errors. So I'll just click play here, and it should get destroyed. You'll see we have in the world outliner chair underscore BP, and as soon as I click play, that'll get destroyed. We have another function that might be more useful in this case. This takes in a float for the amount of seconds here before you want the actor to be destroyed. So once this is called, so let's say after 5 or 10 seconds, you want the actor to be destroyed. I'll Control B to build that. Okay, how to load complete. Again, make sure that you have simulate physics turned on and your actor is set to movable. Then with this other function, again, you want to uncomment this add impulse, you want to uncomment that. Then we'll get that impulse, and then after 10 seconds, this actor should get destroyed. It's in our world right now. You can see it's selected in the world outliner. Once that timer runs out, that actor will be destroyed. So this time is a bit long. You can probably set it to 5 seconds if you want. and you can see that is cleaned up and will get destroyed. So how exactly does this work? Well, if you right click on it, go to the declaration in this case, because here you can see the comments if you want to check those out. Right click and go to the actually peak definition in this case, and you can see it takes in that float. So you can see it uses these timers, and we'll talk about timers in an upcoming video. You can see it does a bunch of things here, and then what it does is it actually calls a function in the aActor class called lifespan expired. So I'll right click on this peak definition, and as you might have guessed, this simply calls the destroy function after, again, that I'll just go and peak definition again, after the timer runs out. So you want to understand exactly how the timer works at this point. As I mentioned, I'll explain how that works later on in the course, but I just wanted to highlight briefly like how this works and why this works. It uses something called a timer, and once a timer runs out, then it will go and call that function, which will invoke the destroy function that we are already familiar with, as we've seen just before this section. So if your lifespan is not greater than 0, so it will go to the else part, then we'll simply clear the timer, and your actor won't get destroyed in that case. So again, many places where you would find this useful to go and destroy your actors, and I just wanted to briefly show you how you can do that before we move on to the next section.